Hey everybody, this is Mr. Longo, and in this video we are going to cover geometric sums. We're going to cover two different kinds. One is called a finite sum, and the other one is an infinite. Now that's a little bit different, so we're just going to take it one step at a time. So to start with finite, that means we have a start and a stop in our sequence. So what we're going to do is use a formula. It's the sum of n terms is equal to the first term times 1 minus the rate raised to the n power over 1 minus the rate. Now the thing you need to know is a rate cannot be 0 or 1. So let's begin. In the first example, we are given the rate is 3. We are given the initial term is 4. We have a first through the 10th term. So what we're going to do here is just plug in our necessary information. So our first term, again, is 4. So we're just going to have s of 10 is equal to 4 times 1 minus our rate, which is 3 to the 10th power, over 1 minus the rate itself. And then all we're going to do is type that in our calculator. And we're going to get that s of 10 is equal to 118,096. And that's it. When you have all the information, you just plug it into the formula, plug that into the calculator, and you're good to go. The second example, however, is a little bit different because we have to go back to our geometric sequence formula. And if you forgot what that was, that is the one where we have a sub n is equal to a times r raised to the n minus 1. And the reason we need to do this is because we need to figure out how many terms we have. So we can clearly see we're multiplying by 2. So our rate is going to be 2. And yeah, you can actually say that that's 24 and then 48 and 96 and 190. You can do that and you can figure out that it's the 7th term. But again, what if it was much bigger than 92 or 192? It's helpful to know how to find out which number term that is. So if you said that this was 192 is equal to, we know the first term is 3. We know that the rate is 2. And we're just going to raise that to the n minus 1. And divide both sides by 3. You get 64 is equal to 2 raised to the n minus 1 power. And there's a few different ways you can go from here. You can use logs, or you can realize that 64 is 2 raised to the 6th power is equal to 2 raised to the n minus 1. So since you have the same base of 2, all you have to do is set n minus 1 equal to 6, and you get n is equal to 7. So that's another way to find out what number term you have in a question like this. Now that you know the term, all you have to do is the sum of 7 terms is equal to the first 3 times 1 minus the rate of 2 to the 7th power over 1 minus the rate. Type that in your calculator and you're going to get the sum of 7 terms is equal to 381. Okay? So that is a little introduction to finite geometric series and sums. Infinite is a little bit different, and here's why. If you have a rate that's larger than 1, there's no way to find a sum, okay? It's because that is called a divergent series. If your rate is bigger than 1, I'm just going to give you an example. What if we were doing 2 raised to the n power? 2 raised to 0 is 1. 2 raised to the first power is 2. 2 squared is 4. Cubed is 8, then 16, then 32, then 64, and it's just going to get bigger and bigger and bigger and bigger and bigger. And if you try to add all of those numbers up, you're going to be into infinity because one number is going to be up in infinity at some point. So that is what you call a divergent series, is because it's going to just grow so fast exponentially you can never find a sum. So when you have an infinite series that has a rate larger than 1, all you have to do is say no sum, it diverges. When your rate is less than 1, however, you can actually find a partial sum. And a partial sum just means like it's going to get close to this number. It will never actually reach it. You've probably thought about this a long time ago when you thought about a half. So we're going to do a half. So if we started with 1, and you took half of 1, you now have a half. And if you took half of that, you have a fourth. And if you took half of that, you now have, you get it. We're going to keep on going. 1/8, 1/16, 1/32, 1/64. But it's never going to reach 0. You're just going to be slicing off, and then you can have like 1 over in the millions, and you're still never going to get to 0. But by adding something that small, you're never going to get to a certain term. Okay? So that is known as L, the limited term, and it means your series is converging. So if your rate is less than 1, you have a series that converges, and we are going to be able to find a partial sum. So let's go give it a try. So example number 3. You know that it's infinity by either the top of your sigma is infinity, or it just says ... It could say infinity, or that doesn't even have to be there. If it doesn't have an end, you know it just keeps on going. Okay? So the first thing you need to check is, what is the rate? So if you have an infinite series, your rate over here is 5/4, which is greater than 1. All you have to do is say no sum. And just say it diverges. And you're good to go. That example, we're done. But if it does have a rate less than 1, up here I gave you a formula. It's just sum of an infinite series is equal to the first term over 1 minus the rate. So for number 4, we have a rate of 0.7, which is less than 1. So all we have to do is take the sum of the infinite series is equal to the first term, which is 3, over 1 minus your rate of 0.7. And then that's just type that in your calculator and you're going to get 10. So we would like to say L is equal to 10, your limited term. That's because it isn't exactly a sum. It is a partial sum. It's not exactly 10. It's going to be pretty, it's like 9.999999999. It keeps on going forever and ever and ever. Okay? So, number 5 is an example for you to try. You can see that the rate is smaller than 1. All you have to do is take your first term of 3 again. I don't know why I did that for the same. But take your 3 and divide it by 1 minus your rate, and you're good to go. Give it a try. So you should have 3 divided by 1 minus, your rate is a negative 1/4. Because remember, whenever you're trying to find the rate, 3/4 divided by 3 is going to give you a fourth. 3/16 divided by 3/4 is going to give you a fourth. Or you can think about the fact that you're just multiplying each one of these by 1/4. However you work to get your rate. However, it goes from negative to positive to negative. That means the rate is a negative. So that's just going to give you 3 divided by 5/4, which is going to give you 12/5 for your final answer. Okay, and that's it for geometric sum. Make sure whenever you're working with these questions, now that you know arithmetic and geometric, before you start answering questions, make sure you look to see if it's arithmetic or geometric. If it is geometric, make sure you're looking to see if it's finite or infinite so you know which formulas you should be using. All right, this is Longo and I'm out. See you, bye.